Okay, but while Phil's doing this, if you came to the session that Phil did on
Tuesday,
the 100-minute session, you should probably get up and leave. We're gonna wait. On Wednesday, there's probably something better you can see because we're gonna do almost the exact same thing. It's just I'm here now. All right, I'm gonna wait. We're not offended.
so did anyone come to my session on Wednesday on Direct Lake? No one? That's good.
Yeah, you
because
should leave.
it is exactly the same
It's
content
exactly the
compressed.
same.
We've
You
got,
should leave.
yeah, I just got to check. Is this being recorded? Yeah, I'm getting nods. Okay, that goes half my jokes.
Yeah.
I'll have HR on the phone. So
You should leave. You should leave because you're not gonna learn anything.
yeah, it was good to check first.
Yep.
So
Okay.
we just had some technical troubles with the video. I've had to reboot my screen, so I'm going to do a little bit of setup. So I'm going to start you with Patrick. But,
All right. Okay, so both Phil and I work on the Power BI Fabric Cat team at Microsoft, and we're PMs. We don't know what program manager means, but that's what we do. Okay. All right. Go to the next slide. And so we're going to talk about what is Direct Lake. We're going to talk about some prerequisites. This is the agenda. This is what we're going to talk about today. And we're going to try to do this very quickly in the next 50 minutes.
Yeah, so what are we going to cover? Patrick, what is Direct Lake? That's pretty important to just set the scene, get an understanding of what Direct Lake is, because it's hopefully quite new. How many people are using Direct Lake at the moment in some shape or form? Okay, we're getting a few hands. So this is going to be new content for many of you. Well, you are maybe in the right place. That's cool. Direct Lake uses Parquet files. So we're going to talk about why we're using Parquet files. What's inside those Parquet files that make Direct Lake work really quickly?
Yep.
Why did we choose Parquet as that format? We're going to be mentioning something called V-order. It's very, very important. We do have a demo, which hopefully we'll have set up for you by the time we get to that section. And we're also going to touch on a couple of fundamentals which are really important to understand about Direct Lake that are new, that you don't necessarily think about with other storage engines, direct query fallback. And finally, I've got some numbers on performance if we've got time. We'll just see how we're tracking, but we will get to a demo.
Yep. Okay, so what is Direct Lake? So this is just a traditional deployment of Power BI. We have your relational SQL server, your source data, and your Power BI. And initially, there were only two primary storage modes in Power BI. There was direct query, and direct query is super fast when you work with a little bit of data, okay? When you work with a little tiny bit of data, direct query is really, really fast. The way it works is Power BI generates some DAX. It takes that DAX, converts it to the dialect of the source. So let's say you're using SQL Server. It converts it to T-SQL, and then it runs that query and brings it back. If you have a little baby amount of data, it's really fast. If you have a really good DBA with a medium-sized amount of data, it's probably good. If you have a really good DBA with a lot of data, it could struggle. And if you have any type of data with a bad DBA, it's really going to be bad.
Yeah,
okay?
and what you typically care about, if you're in charge of running or authoring a model, there's really three pillars that you like to focus on. The first is, how long does it take for me to get data into my model? So that's what the first column here is trying to show you. Secondly, once data's in your model, how much space do you need to store that model or host that model? That's the second column here. And then finally, probably the most important one is, what's the query speed going to be like once I've got it all in place and I've done all the best practice things like that? So yeah, here we're showing for the two storage modes that are available today, we've got happy faces or question marks in the sections.
We're not sure.
Yep.
And so when the data grows, though, what happens? Which will refresh it. So with direct query, it's just got to query it. But with my refresh, it takes a bit. I got to pull that data in. You got to call Phil. You got to call Adam to do some aggregations. Maybe not Adam because he's a manager now. You got to maybe do incremental refresh. You got to do different things to quickly get that data in. And it has to do all this encoding of the data to put it into memory and this compression. Yeah. But how do we do that with these very, very large models? And then that Microsoft introduced a new storage mode. It's called Direct Lake. Direct Lake is a little different. And you see all the happy faces there, right? All the happy faces.
On those three pillars, absolutely. So even big queries, you don't have to worry about managing import processes. Because when you have a very large data set and you're using import, you've got to think about partitions and incremental refresh and maybe composite models, aggregates. There's a lot to think about. So with Direct Lake, hopefully that's just gone.
Gone, right?
But you still get good model sizes and you still get very good query speed like you would do in import.
So now that you mentioned model sizes, Phil, so on premium capacities, we have a P1, a P2, or a F64, whatever you want to call them. And each one of those have a max model size of 25 gigs or 50 gigs, whatever. How does Direct Lake play into this?
Well, we're going to get to that.
Okay. Am I moving too
No,
fast?
no, no, it's good.
Okay.
No, it's a fair call.
Okay.
Because one of the neat things that Direct Lake enables is column-specific paging. And in fact, I'm going to
So
jump to the next slide
Next slide.
to, there
There
we
we
go.
go. There we go. So that the third line, and we talked about this yesterday. We were
Mm.
talking about this because a couple of people asked this question, and so it only works with one source. Direct Lake model start its life with data no memory. So there's no memory like an import mode. But this third bullet, right? Data is paged into the semantic model on demand, triggered by queries. And so this question came up when Phil did this, and I wrote it down in my notes. And it was a person sitting next to me, and she was like, "Hey, but when I run a report, it pulls some data in. So it pulls 4 columns in. What if I change it and add the 5th column? What happens, right? And so it pulls all the data for the given columns that the DAX query produces into memory. So if I say, give me all the data for this year, it doesn't just pull this year. It pulls all the data for that column for all the years
But it
in
does
the
it
memory.
quickly.
But it does it
You know,
quickly.
it sounds like
But
a
it does
really
it
bad thing
quickly.
to do, but it's very, very fast.
But
And
some columns can be in memory and some columns cannot be in memory. And later when we talk about framing, Phil will show you, we're gonna do a demonstration of creating a semantic model and running some queries, and you'll see that some data goes into memory and some data doesn't go into memory.
yeah.
The tables, that's the next bullet point. They can have resident and non-residence column. They can be evicted for many reasons, and there's some new properties added to some DMVs to the columns to let you know the temperature, and we'll talk about that in just a little bit. And the challenge, though, is we put guardrails around this direct lake. And so there's some reasons that it'll fall back to direct query, and we'll talk about that later.
Yeah, but a
Go
really
ahead.
fundamental difference between direct query and say import is import needs to have all the data brought into it, loaded, the refresh process complete, before you can start running DAX queries against it. It needs all the data there, probably all the columns for all the tables. But a direct lake semantic model,
Semantic
keep want
model.
to say data set, a direct lake version starts life empty. When you create it, has no data whatsoever. Data only gets pulled into the model. It's triggered by DAX queries, and it will only pull the columns in needed for the given DAX query. And when the data gets pulled in, and it sounds slow, but believe me, it's really fast, it stays there. It doesn't disappear quickly, like with direct query, for example. Every single query, nothing's gets saved. Even if you run the same query over and over
Yep,
again,
yep.
you get all the same round trips. But with direct lake, data gets paged into memory on demand and will remain there for hours. We can bring it in fairly quickly. But if you've got a 200 column table and
They'll
you're
be
only
gone.
querying 5 columns in that table, we don't pull the entire table in. We only grab the columns that we need, put that in memory, and that allows you to keep the memory size a lot smaller than, say, an import equivalent, but you still get the import-like performance.
Yep.
And eventually they'll get paged out.
Yep.
Are we ready for the next slide?
Yeah, we're ready for the next slide.
It's like a birthday.
Yeah.
Not quite
So-
sure what's coming.
So there are limitations. There are limitations. And so probably two of the biggest limitations is there's no calculated tables or calculated columns right now. And everyone's like, oh, we need calculated columns. Why? Why do you really need calculated? Do it in the source. That's what Matthew Roach said. As close to the source as possible. Don't do it in your model. No calculated columns at all. I kid. Just not in direct lake. There's no composite models. This can only be used with tables, not views. If you create a view in your data warehouse, it's going to fall back to direct query. That is a limitation of it, right? It only can be used with security defined in the model. So you can go put row level security in your data warehouse. You can put object level security in your data warehouse. It's going to fall back. It's going to fall back. Okay? And not all data types are supported. And then there's a great doc. I think it may be in the comments of this slide. I think I put it in the comments of this slide that talks all about the nature of what those guardrails is and what it'll fall back to direct query. Okay, and so it's only supported by certain SKUs. So Pro, Premium per user, the embedded SKUs, you can't do direct lake with it. So if you have those, can't do it. You need Premium or Premium per user. Premium or one of the Fabric SKUs, not per user, not per user. All right. And so right now, you need to create a lake house or a warehouse to get started with this. You create your lake house, you create your warehouse, and then you can go into direct lake mode. Once you build your model, you point to the tables there. Even if you create shortcuts to tables in your lake house, it still works.
Yeah, me?
Yeah,
Cool.
you.
All right. So one of the key points that we had earlier about how direct lake works and how it's different to import and direct query is it only can work with one source type. With an import or a direct query, you can connect to Redshift, Snowflake, SQL, all different flavors of SQL on premise through gateways, etc. But with the direct lake model, it only understands one source. And this is why it can actually do what it does very quickly, because it understands that source. It can make some assumptions and take shortcuts. Because essentially what it does is when you do run a query against a direct lake model, semantic data set, whatever we're calling it this week, and we have to get page data in, all it's essentially doing is lifting and shifting the data that's in the file and dropping into memory. Because it's very similar to the way that, or Parquet file format is very similar to the way the analytics analysis services likes to organize the data in the model. And that's why we can page data into memory very, very quickly. So Parquet, we've chosen Parquet, and the reason why we've chosen Parquet is because it is an open format. It's not I mean, it's used by many BI vendors these days, and its column-oriented format is ideal for analysis services. And I've got a very simple sample data set that we walk through. I show you a CSV version, an XML version, a JSON version, and the Parquet version. You'll see we pivot the column data around so it's all organized together. We'll jump to that very shortly. It's very good at compressing. That's important for analytics. And yeah, generally it's the lingua franca for a number of BI tools. But the last point's quite important. With Fabric, what we do with our Parquet files is we enhance them with vOrder. Now, vOrder is just extra compression. And this compression is good. This might set off some alarm bells in your head, because normally when you compress something aggressively, you have to burn a lot of compute to do that, but you also have to burn a lot of compute to uncompress it before you can use it. The good news about analysis services is not only can it read highly compressed Parquet file format, it loves it, it prefers it. Now, vOrder is only available in Fabric, as I said. Now, that might also set off a red flag in your head thinking, hang on, does that now mean I'm locked to Microsoft? If I get my data into Fabric and I do this vOrder stuff, yeah, my reports will shine, but what happens if am I locked in now? No, you're not. The vOrder still conforms to the open standards. So if you wanted to, you could generate a Fabric set of Parquet files, Delta table. You could take it out of Fabric and you could open it on a non-Microsoft BI tool. And not only will it be able to open it and read it and run queries over it, so long as it conforms to the open standards, it'll do it faster than if it was running over exactly the same data set generated by itself. How long have we been working on vOrder? Since 2009, which probably doesn't make too much sense because Fabric was only announced last year. How is that possible? And that's because the tabular version of analysis services came out about then. And we started working and developing the algorithms to compress data as it gets read into the model, Vertipack, and we've been improving that, refining that over a long period. That's essentially what we've shifted, called vOrder, and we can apply that same goodness to the Parquet files to get that extra compression, and you'll see the benefits later on in this presentation, but you're absolutely not locked into Microsoft. This is not old Microsoft, this is new Microsoft. So let's have a look at a bit of a data set. Here is a 3-row table with 3 columns, I think, in CSV format. Now, we all know CSV, very human readable, but it's row-based. So if I want to perform some analytics like just do a sum over that final column, if I want to know what is the total value for everything in that final column, I still have to open and scan through every single character in that CSV file. It's not especially efficient, and it doesn't compress well. The next format, let's see the same data in XML. I can't even fit it on the screen. So the first row would look like this. Like CSV, it's very row batch orientated. So again, if I wanted to perform a calculation such as just give me the sum of the value column, I've got to do a lot of scanning, I've got a lot of read, a lot of things just to get to those 3 values to perform that calculation. And the next one is XML, JSON. which is really just a prettier version of XML, a bit more elegant. You're using braces instead of the greater than, less than signs, but same problem, row-based, so not great for analytics. And finally, if we jump to Parquet file format, you'll see how the data layout is quite different. So we take the columns and pivot them around. We organize all the store A column data together in one place, all the date time stuff in one place, product ID stuff in one place, and the values, etc. And we do clever things like run length encoding. We shuffle things around so that if I happen to have the word store A 3 times in a row, rather than write it out 3 times, we might just say store A x3, or whatever the code equivalent of that. But you can see if I wanted to do a sum of the value column, I can skip a huge section of the file. I can just jump to that column, go quickly get those numbers, and perform a sum. And a Parquet file will have headers, it'll have footers, blocks of data can be organized into these row groups. From those advanced in the audience are familiar with things like partitions and segments in analysis services. A row group in a Parquet file has a one-to-one match with a segment inside analysis services. And understanding the data layout can be beneficial for things like performance analytics of queries. They can impact on that. But if you click to the next slide, please, Patrick. We don't actually store the value store A and store A and store A. The values are stored using dictionary values. Do you want to jump back? Awesome. So every single row group has its own local dictionary. So apple might have a value of 1, banana might be 2, cherry might be 3. Unfortunately, the next row group, it might be different. Apple might have an ID of 2, banana might be 1, and cherry might be 3 in this case. Why is this important? Because when we are going to grab this data from the Parquet file, like let's say someone's run a query in my DAX engine and says, I just want a sum of value. We can go out to the Parquet file and just quickly find the values and bring them in. But what we have to do is some translation of the dictionary values, because inside Power BI, we only keep one dictionary. So apple is always 1, banana is always 2, cherry is always 3, for example. So it's really important to understand that, because if you've got a high cardinality column with a huge number of potential values, then it does mean the time it takes to page data into Direct Lake at query time can be influenced, use a lot more compute. So what can you do to help? Certainly double check the data type you're using. Think about cardinality. So if you've got a column that happens to be date and time together, split them up like you're normally probably doing already today, so that you've got a date column and a separate time column. Reduces the cardinality, reduces the maximum number of dictionary values, and it does mean when you are using Direct Lake and you want to quickly get data in, lower cardinality stuff can help. So if you've got a numeric column that has decimal places out, 10 decimal places, you probably don't need that. Switch it to currency or whatever the double or decimal, I forget what they are. So there's only 4 decimal places. The cardinality will shrink, the number of dictionary values will shrink, and paging will perform quickly. That's probably one of the challenges we're seeing most often for people that are testing the water with Direct Lake. I'm still trying to log into DAX Studio, I think. So yeah, just a quick summary. What is vOrder? So vOrder. I love vOrder. So it is a proprietary optimization. You'll only get it on Fabric compute engines. You'll never get a standalone version. Probably the closest you'll get it to be able to apply vOrder to something outside Fabric is you can run vOrder compression over a shortcut. If people in the audience are using Databricks, you might be outputting to ADLS Gen 2. You can actually optimize that even further by running a process to apply vOrder. But of course, if you have to do it after every time it gets rewritten. I'm going to have to probably put my password in somewhere here. And yeah, we've already talked about the fact that it can be read by any other tool that can read delta tables. And I've got the next slide. If we jump to the next slide, the performance, we've got some real-life case of Microsoft data. So we had some sales data that we extracted and stored in CSV, that row batch, which isn't great for compression. But when we did that exercise, it was nearly 1 terabyte in space on disk, 880 gigs. Now, when we converted that to standard Parquet, because Parquet is really good for compression, it came down to 268 gigs. So it was about 1/3 the size, which is pretty impressive. But vOrder took it down to 84 gigs, so it's almost 10 of that original size. And remember what I said, in other technical domains, when you aggressively compress something, you have to burn a lot of CPU to do that. and you also have to burn a lot of CPU to uncompress it and time before you can use it again. But absolutely, Power BI not only can read the 84 gig file, it loves it. It can just give you the correct numbers so much faster than the query that would run on the middle, or you wouldn't even bother trying to run a query over CSV. That's just not too good. So, and I can't remember what the times 32x is, but
Yep.
so I've
How
got a
much you
demo. I'm going to jump into DAX Studio.
So one of the things that you really need to consider when you're designing your direct lake models, all the best practices that you were doing when you did your import models, don't forget them. Don't forget them. Phil just validated that when he was talking about the data types, because cardinality can still be a problem. When you have high unique values in it, it's still got to move it. It's still got to encode it to bring it into memory. And then, like you said, with all the different dictionary values. So if you deviate away from those, are you ready? From those, uh, from those best practices, then it could quickly slow down even your direct lake model. So while Phil's doing that, any questions?
Yeah, now's a good time for questions.
Yeah. Okay. I can't hear
And
you.
repeat the question.
Ah. So the question is, when you design a direct lake model, do you have to share the warehouse or the lake house? At a minimum, you have to share the endpoint. The endpoint, the SQL endpoint that comes with it, so it can have access to the underlying data. Challenges is if the security's there, it's going to fall back to direct query. So can I have two? So in a data set, can I have a warehouse and a lake house? And when I create my semantic model, can I have tables from both the lake house and the warehouse? You cannot. What you can do is, if you have a lake house, you can create shortcuts to the warehouse tables and then build your semantic model on top of that. Other questions? Are you ready? No, not yet.
I'm nearly ready.
Okay.
Just having some.
Yeah. Can you speak up? What does V order now mean? We're going to talk about that a little bit towards the end. Is that okay? We're going to talk when Phil does the performance section. We're going to talk about that. Any other questions? Dang it. Dang it. Okay, yes, sir. How does the data types from Power BI align to the data types in Delta format? So how do they translate back and forth? It's a pretty good translation. We just don't support more of the unstructured type of data types in there, like binary. It's still like Power BI, but Power BI didn't support those types of things. There was another question. Somebody hand with it. Is there any limitation for DAX? No.
No.
No DAX limitation. But you
No.
still need to make sure you follow the DAX best practices. Don't do filters over very large tables. Keep doing the same thing that you read all about in Phil's blog post, right?
Okay, so my laptop's decided to run really slowly. What we'd normally be doing at this point in the session is to jump to DAX Studio, but I can't seem to authenticate. It's spinning. I've closed it and reopened it a few times. I'm also trying to open a notebook, and it's really slow. So it's either my laptop or the Wi-Fi or something that's going on.
Let's blame it on the Wi-Fi.
Yeah.
Okay, we'll blame it on the Wi-Fi.
It's probably my.
Okay.
So we're going to talk through this.
Okay.
The demo.
Okay.
So what would happen normally when everything was behaving, like pretty much all morning, is
Wait, let's say one thing first.
Yes, you go.
The only where right now today where you can create a direct lake model is in the model view in the service.
No, that's not true.
Tablet editor.
Tablet
editor too, right?
Yep.
Tablet editor. So you need to enable read-write on your XMLA endpoint if you want to build it in tablet editor. But the primary design place, let's say that the primary design place today is the model view. You can't. The point that I'm making is you can't do it in Power BI Desktop yet. Okay, so you can't create direct lake models in Power BI Desktop. Go ahead, go Phil.
Okay, so we're going to do this on the fly.
Okay. I don't know if that's a good thing,
because my DAX
but okay.
Studio's not playing up, we're going to use a notebook. We're going to use SemPy to run the DMV, and we're going to run the queries.
All right. So SemPy is a Python library that you need to install in the notebooks, but it allows you to interact with your semantic models using Python. Fair enough?
Mm-hmm.
Right? And so we have some samples here.
I'm going to go new notebook. So yeah, I've got a lakehouse with some data. And we're going to create a semantic model and then run a query over it. But what I want to do is create a notebook that allows me to run some queries against it. Because that's going to show you data getting paged into memory. We're going to run a DMV first to show you that no columns have been paged in Then we're going to run some DAX queries one by one, and then run the DMV again to hopefully show you how the model has been hydrated, how most of the columns are empty. And we've got some pretty big tables to run it over, but
We'll
might
see.
not work. We'll
So
see how this goes.
the big difference, if
Cool.
you think about an import model today, when you look at VertiPack Analyzer, for example, if you're using DAX Studio, how many of you familiar with VPAX? Okay, so you can actually run some DMVs that tell you, how much space a particular column, the percentage of memory that this column is taking, or the percentage of memory that this table is taking. When you run this DMV, it's a very similar DMV. When you run this DMV against a model that's in direct lake mode, none of the data is in memory. The model is completely empty. And so the very first time you issue a query, and that's what Phil is about to do in this demo, the very first time you issue a query, it's going to look at that query
Ooh.
and say, I need this column, this column, this column to provide the results. And it's going to run that query against the model, against the Parquet files, and bring that data into memory. And so most of it's already, so the Parquet file is already compressed, so it doesn't have to perform those actions. It just needs to do a little transcoding to bring that data in.
I think my DAX Studio is coming to life.
I'm doing it, man.
Yeah.
This is all on the fly. All right. Any questions? It's all on the fly. Yes, sir. I can't hear you. Nope, 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 nope. It's not merged, but go ahead. Yeah. Yep. To direct lake, does it switch? So the question is, if I'm using import and I, create a visual and Power BI generate the DAX, and then if I use direct lake in Power BI and I use a visual and Power BI generates some DAX, is there differences? There may be some slight nuances, but for the most part, those DAX queries should be the same. There shouldn't be anything different about it. It's just the behavior about the memory, right? And so we've been paging memory. We've been paging data into memory with import models a long time, right? We just called it, I think it was VertiPack paging or something like that. I forget the technical term. So this is not new, like Phil said. We're doing it different. We're not requiring you to pull all the data initially in the memory. We're just saying, hey, when you issue queries, bring it in. And now, if some of you may be thinking, well, what about the first person that hits the report? What's the behavior for them? Hang on. You can't get up. You can't leave. We're going to talk about that at the end. See, I'm like a Jedi. I'm reading your mind. I'm reading your mind, right? Are you ready, Phil?
No, my.
Okay. Yes, sir. So his question is, can you improve the performance of direct lake by doing maintenance on the Parquet files in the lake house? So there's some maintenance options that we talked about in our session yesterday, like vacuum and optimize and things like that. So if you think about how Parquet files work, every time you insert update, it creates another Parquet file. The more Parquet files you have could potentially affect performance. So if you do run vacuum and optimize, it can absolutely help improve the performance of your direct lake model. Yes, sir. If I create a shortcut to Databricks Delta tables. Yeah. So the question is, if I create a shortcut to a table that's created in Databricks, and so Databricks is producing the Delta Parquet files. Databricks has an option to do Z order. Okay, so the Z order is it's an optimization for Databricks. You can combine Z order with V order. Now, when I run it, I can connect with Power BI and create a shortcut to it and run it. You may not get the exact same performance that you get when we add our V order on top of it. Our V order is optimized for our compute engines, so you may see some degradation in the performance. So when you add the V order, I would suggest test it. But I would assume the V order is faster. If we get to this point in the presentation, Phil actually has some numbers where we did some benchmarks, and he shows the comparisons. Not that much. When the V order and Z order are together, it's pretty close to just the V order. I'm sorry. Yes, absolutely. It's a trade-off. You ready? Okay, other questions? Yeah, I'm behind you. When is it going to be available? I don't know anything about that.
What was the question?
About Snowflake mirroring.
When's it going to be available in
No,
Snowflake?
so it's when you set up mirroring, because I think we talked about mirroring we talked about it at Past Summit and Ignite. So we talked about database mirroring there. So when you mirror, it creates Parquet files in the warehouse automatically. So it should work for you. Yeah. Yep. So when I create my model in import mode, so let's say I have a single fact table that has surrogate keys on it, and then I have a dimension table, let's say product, it all has the surrogate key with natural keys in it, and I want to leave those natural keys behind when I design the model. Is that what you're asking? So today, when you create the model in the model view, you don't have the ability to say, I don't want this column. But if you go in Tablet Editor, you can adjust it. I think. No, you can't, because that's a Power Query thing. You
All right,
can't.
so I'm good.
Let me actually listen to this question.
Yeah,
Listen to this
yeah,
question.
yeah, yep.
I'm not sure. I'm not sure. Maybe Phil knows the answer. So in import, you know how you can say, okay, I got this table, and I don't want to include this high cardinality column.
Mhm.
Okay, when you do import, I go into Power Query. I say I don't want that one. I don't want that one. I
Yeah.
don't want that one. Because I can't do a view. Because I can't do a view because a view is going to fall back to Direct
Correct.
Lake.
Yep.
Direct Query. In Direct Lake mode, I don't have that ability.
No, no, you just need to make sure the delta table doesn't have that column.
Yeah.
And you can create as many delta tables as you like.
So you can't. You got to do it upstream. Yeah. Okay, one more question, and I think Phil's ready.
Yeah.
Yeah. Yeah. God, I can't. I'm sorry. Yeah. Yeah. Okay. So in regards to security, row level, object level, that type of security, right? It has to be in the model. You can't put it in the source. You can't put it in warehouse well, you can't do it in the lakehouse right now. But you can't put it in the warehouse. If you put any type of object level or column level security or row level security in the warehouse, and you give me access and I'm accessing it, and through it'll fall back to Direct Query. So you got to do it in the semantic model.
All right.
Wait. They do. They do. They do. They do. We're working on it. We're working on that. There's a conference next week where some things may get announced, but we're working on it. You have to share the warehouse. I can, No,
Okay.
you can't. You can't. You can't. You can't
Sorry.
do that.
We need
You can't
to
do that.
crack on.
Whew.
So the plan B,
Man.
I still can't get my DAX Studio running, which is not great. But what we're going to do is try and do it in Senpai, in a notebook. But the thing we need to do is create a direct lake model. That's starting point.
That's where we're at.
So how do we start? How do we create a direct lake model? I'm in a lake house here. The lake house has got a couple of dimension tables. These are quite small, date, device, and geography. This is real life data that we've anonymized, some telemetry stuff, so it's got all those ebbs and flows. I've got a bunch of billion row tables. Let's create a semantic model against some of these tables in the warehouse.
So this is where we were talking about. So this is where you would create the model, but if you have your read-write enabled on your XMLA endpoint, you can use Tablet Edit Connect. If you want to use a different tool, and you can build it there. I did a video, I don't know, a while ago, and hacked out creating field parameters. Don't do it yet. They're about to. I think it's going to be supported. Field parameters are supported now, right?
I can't remember actually.
Yeah.
Sorry.
Okay. Go ahead.
Please wait. Please wait.
Oh, we're
please
still
wait,
waiting.
Please
We're
wait.
still waiting.
This is where I normally go to my repertoire of jokes.
Give us one. Do one. Give us one, Phil. You're not. Okay. Whew. We have to reboot. That kind of.
Okay. So essentially what we're going to be doing here, it's still just, going to be one of those sessions, I think. We create the model. When this dialogue finishes, it's going to land us into a web-based authoring experience, very similar to what you're used to in Power BI Desktop. But the great thing about this web-based model authoring experience that we've got here, and you want to sort of create some relationships maybe,
Yep.
is that it doesn't matter what operating system you're using. You could do it on a Macintosh browser. It doesn't matter if you were dealing with billion row tables. They're not going to get sucked down to your laptop on your slow rural broadband, for example. It's, there's a lot of advantages of having this, but you need the model. And what Adam's hopefully doing is just creating a couple of...
Adam.
This
Oh.
hasn't been recorded.
Have a great day. Oh man.
What time's the party? Um, so yeah, but when we're creating the model here, nothing's actually going into no data is going into the model. It really is just a collection of column names, and you can write measures in here, but it's completely empty. Now, the idea is when this is created, what we do is we open something like DAX Studio, and we run a DMV, a special DMV, that just says, what is the data status for every single column? And the very first time we run it, it lists out every column in the model, and there's blanks, and a couple of columns called temperature and last time it's run. And then what we do in the demo is we just say, let's run a max over the holiday name column in the date table. Runs really quickly. Now, what happens at that point? When you highlight the piece of text, which is the DAX query, and hit the play button, that piece of text goes to the database engine, analysis services, and it converts it to a query plan. And in the query plan, it goes, what columns do I need to be able to resolve this query? And in a simple query like that, which is just max of column, I only need it. Then the next check is, do I have that column resident in memory? And because we know we've just built it, it's not there. We ran the DMV, it's not showing. And at that point, Direct Lake goes out to the lake house, says, give me everything you've got just for this column, and pulls it back in. So it goes into that Parquet file, jumps straight very quickly to the row group, just the section that is, has the data for just that column, pulls it back. And it does it for the entire column. So if you've got 10 years worth of data, billions of rows of dates, and you're doing sum of yesterday, sum of sales for yesterday, it'll still go and suck in the entire column. But it should do it very quickly, like within seconds, even less than a second, depending on cardinality and factors like that. So I run my max query, then we run the DMV again, and you'll see now that the result set changes, that the column that we just queried is now resident in memory. And we run some extra queries. If you run some that have got columns from more than one table, you'll see not only the columns used in the query are brought in, but the columns used for the relationship are brought in. But they stay there. This is a big difference between Direct Lake and perhaps say Direct Lake and Direct Query. But if you go away for the weekend, you might come back on a Monday morning and find it's all been evicted again because of no activity. But first time you run a query, boom, columns start hydrating again. You might have a P1 that's got 25 gig of allowed data, and you might have 28 gig of actual data. Theoretically, what will happen is, as the model fills up, and you run a query that needs a column that's not necessarily resident in memory, we'll start evicting other columns so that we can page it in. You can end up in thrashing situations. You kind of got to keep your eye on that. We have a tool called Delta Analyzer that can help you understand things like the size of the column, but
Do you already have a model created?
no, I don't. I don't think so.
But you still can use, you can't use the 2 billion row one, but the
Yeah,
1 billion
yeah,
one.
we can probably run a ticket because it doesn't need necessarily a relationship.
Yeah,
So let's try and
yeah,
run a query
yep,
against
yep,
that.
yep.
So I'm going to go to my notebook, and I created that table called Phil's model, and let's just try a simple query. Hopefully this actually turns out quite quick. So we're using Python here to run a very simple DAX query against the model that we just created or trying to create. Because I want to see if I can at least run the DMV once. I'm sort of stubborn and determined now, but we have got framing to talk about, and we have got fallback to talk about, and they're really important concepts, and I think we've got 7 minutes
about out of
left.
time. But the
Yeah,
point,
so
the
I
point here, though, this is really important. And so once you install this Python library in your notebook that you're running, you can run DAX queries directly against your model. So you can do lots of different types of things. But Phil is going to run a DMV, and the DMV is going to show you which columns are actually pulled into memory.
No. Let's jump to framing.
Okay. And what's going to happen? What would happen once that data is in the memory? Then once you do frame, what we're about to talk about, it actually clears everything out. Go.
Yeah. So you're doing framing. I'm doing framing. Framing.
You go frame.
Okay.
You go. I'm tired.
So one of the challenges with paging columns in like that is you could get yourself tied up in knots of your report. You're really worried about things like consistency. What you don't want to have happen is someone come along in your lakehouse and make some changes to your dimension table, but not your fact table, and someone runs a query and you get very inconsistent results. Now, you don't need to worry about this with import because usually what happens is at the end of an ETL process, all your tables are consistent. They all match each other nicely. You can run your import process. Once it finishes, half an hour later or whenever, all the tables in the model are nice and consistent. You have to be careful with Direct Lake because you don't know necessarily who's messing around with your uh, delta tables. You might have a very long ETL process which is taking its time to do truncations and inserts and whatever. If someone's using Power BI at that point, they may get inconsistent results. So there's this concept called framing that allows you to draw a line in the sand based on the point in time that you signal the framing operation to take place. What that means is everything that happens from Power BI then on only considers data modification up to that point. And I've got a little bit of an animation that might, if we could jump to the animation, because I think this might help explain what's going on. So let's just pretend I have an empty table in my lakehouse and I insert just 3 rows of data, 1, 2, 3. What that does is it creates the initial Parquet file with that information inside it. When I perform a full refresh on my semantic model, it's instant. All it does is evict any data that might be there. Then what happens is if someone comes along and queries my table, they'll see these results. They'll see 1, 2, 3. Now if you click to the next one, in my lakehouse, someone comes along and inserts some data, such as 4, 5, 6. It doesn't pack it into the original Parquet file. You get a second Parquet file with its own timestamps that include the new data. But if I don't reframe and I run the query, if you go back one, oh no, it's okay. If I run my select star from table in DAX, I don't see the 4, 5, 6 here. I still only see the 1, 2, 3 because the last framing operation that took place was at the end of the first insert operation, but not the second one. Now, if you click and reframe at this point and run the DAX query, I now see the full result. So if you click through quite quickly now, if we insert 3 more rows, you get a third Parquet file, and now you reframe. So yep, cool, and now you run your DAX query, you get the whole lot. You click it again to go to the next operation. Someone comes along and deletes all the rows. We don't delete the Parquet files. We create a 4th Parquet file, or we do some special magic in the background, but the actual 1st, 2nd, and 3rd Parquet files are still there. So because we reframed before the delete operation, even if we evict all the data and we reload it somewhere else, what happens is when your DAX queries come in and start paging data into memory, they use the information that's stored in the first 3 Parquet files and they ignore the 3rd ones. So you can write some time travel queries. I did do some demos in the video. That's probably the better one to watch if you want to catch up on this elsewhere. But it's an important concept. When you create your default data set, it automatically reframes every single data modification operation, so you don't need to do that. You don't want necessarily that on all your models. Some of them it suits perfectly. So if you've got small teams doing little bits and pieces, they don't probably care about consistency. They just want to always see the latest data. So if someone is coming along and doing these type of operations, your Direct Lake model will always show the latest data. But if you've got a very big important report that you want to control and manage, then you need to make sure you issue the statement to perform that reframe operation in your ETL process. So whatever you're doing for your ETL orchestration, do all your ETL, get all the data right in your DIMs and your fact tables, then when everything's green, refresh the database and click. I think there's where you can do it from. So default models, it's automatic. You can turn it off. You can do it manually in the Fabric service. You can schedule it. You can do it via notebooks using SEMPI. You've got APIs, Power Automate. I think the next slide is just more of the same on framing.
Yep.
So yeah, you can do it in Timsel. Now the advantage of doing something in Timsel is you can frame individual tables. So you don't necessarily have to frame the entire model. And Timsel can also be applied in things like SEMPI. So these are some places that you can do framing. So lastly, we can jump to fallback quickly if you want to summarize.
The internet's just or somebody's on this capacity field. But the point. So before sorry we couldn't get to this. But you can actually go. There's a property on your data set. So if you go back, we talk back to framing. There's a property on your data set where you can tell it, hey, do not automatically sync the changes from my lakehouse into my semantic model. Because like Phil said, if you're doing a large ETL process and people are changing things, you don't want that to automatically get flowed through because maybe the data is not fully refreshed. Maybe that column's not populated, and you can have inconsistent data. So you turn that off. You turn that option off so it's not automatically syncing. And then, as part of your ETL process, you can use a notebook and you can use SymPy to just say automatically refresh my model. So you just could write a small, it's like a one line of code to refresh your entire model. So after the data warehouse load happens, it'll reframe the entire model, and then all your tables will be there.
All right,
Okay.
fallback in 2 minutes.
2 minutes and fall back. Give us 2 minutes. And so think about, there's guardrails. Can you go to that slide with the table?
The numbers, yep.
Yeah.
Cool.
And so there's a table out here, right? This table is out on the web page. And so each capacity has guardrails placed around it. And so I think we're running the F64 right now.
Well, running.
Yeah, we're on an F64. And so you can see that if you have more than 1.5 billion rows in a table, it's going to automatically fall back to direct query. And so we've placed these guardrails around each capacity to ensure that, it's to protect the CPUs, but if you're running a F2 and your table has more than 300 million rows, it's going to fall back to direct query. This is where the question you asked at the beginning, this is where the optimization of the Parquet files really come into play, because if you have more than that 1,000 Parquet files for that particular table, it's going to fall back. So that's why you need to optimize and do vacuuming and things like that.
Yeah.
So sorry, we had all the technical difficulties with the internet and stuff at the beginning. We apologize. We're going to head over we're going to Power Hour after this, and then we're going to spend the afternoon at the booth. So if you have more questions about Direct Lake or anything about Fabric in general.
But as I said, I did do this session on Wednesday with no technical glitches
None.
whatsoever.
And
so if any of this you want to actually see the longer, more detailed and working version,
go watch the
then
video.
please have a look out for that. But otherwise, come and hit us up. Thank you so much.
Yeah.
Sorry about the technical issues.
Sorry.
Otherwise, have a good conference and see you at the party and